Right. So we are starting with exercise 1, question number 5. Sorry, question number 1, 5, and 6. These are the questions we'll start with. Then moving on to more questions. So third also. Okay. So let's start with question 1. It says that the sum of magnitude of two forces acting at a point is 16 newtons. So let's say we have two forces F1 and F2. Okay. So the sum of their magnitudes is equal to 16 newtons. I mean, the sum of the magnitudes, so that means this quantity plus this quantity is equal to 16, or in short language we can just say that F1 magnitude plus F2 magnitude is 16 newtons. Okay. If the resultant is normal to the smaller force, okay. So let's assume over here that suppose F2 is smaller than F1. So it says that the resultant of the forces, which is the sum of these two, so this resultant is perpendicular to F2 because F2 is the smaller of the two, okay, and has a magnitude of 8 newtons. Then how much are the forces? Then F1 and F2 magnitudes we have to find. Okay. So as usual, we can do this by both component algebra as well as by the triangle law method because we are talking about perpendicular. Okay. So if I go with the geometrical method, might be easier in this case. How we can interpret this is that, okay, let us say these are our forces F1 and F2. It must be something like this because their resultant is perpendicular. So this resultant is perpendicular. This is F1 plus F2, whereas F1 is this one and F2 is this one, let's say. Okay. Now we know that F1's magnitude plus F2's magnitude is 16. The resultant is perpendicular to F1. Okay. And we know that the resultant has a magnitude of 8. Right? That is what the question said. The magnitude of the resultant is 8. So I know here that this angle is 90, which I've already labeled. Okay. Then additionally, if this is 8, and suppose this one is x, then this one is 16 minus x, because the sum of their magnitude is 16. So now I can make use of this, that 16 minus x square, it is a hypotenuse square, F2 square, is equal to x square plus 8 square. Or basically what I'm saying is that F2's magnitude square is also equal to F1's magnitude square plus the resultant square. So that means this one. So now just expand this and you'll see you get 256 minus 32x plus x square is equal to x square plus 64. So we'll get 32x is equal to 256 minus 64. So we can just write this like this, that x is equal to 16 square minus 8 square. It will actually be easier to write it like this. This is 16 square minus 8 square. So we can write this as 16 plus 8 into 16 minus 8, easier way of solving. 132. So 24 into 8 upon 32. So 4, 6. So you can see that x is equal to 6. Okay. So therefore, F1 is equal to 6 and F2 is equal to 16 minus 6 or 10. But this becomes wrong because what happened is x is equal to 6 is fine, but it is clearly said that F2 is the smaller force of the two. Okay, so therefore it must be F1, which is 16 minus x, and F2, which must be x, because x is smaller than 16 minus x. So this must be the case then. Okay, and therefore my actual triangle looks more like this. Actual triangle, just a moment. F2 is the smaller of the two forces, and the resultant is perpendicular to so in that case the resultant is perpendicular to F2. So it basically means like this, that this base one is F2 and this hypotenuse is actually F1, and this must be the resultant. Okay. So this is the complete solution of this. So this is the resultant, which is 8 in magnitude. This one which it is perpendicular to, this must be F2, which happens to be 6 in magnitude, and this one is F1, which happens to be 10 in magnitude. Okay. So this is the final solution of the question 1. Now I'll also show this to you by the component algebra method, but first you can just go through this and understand this carefully. Question 1 of exercise 1. So hope you are following this, people, and this clear. If there's any confusion, any doubt, please drop me a message and let me know. Yes, Samarth, about your reference books and all that, I will be talking at the end of the lecture today before we finish. So you can please remind me once about HC Verma if you like at that point of time. Sarvesh, if this angle was not 90 degrees, then we would have used whatever angle was given, and we would have used the formula of triangle of vector addition. Instead of Pythagoras theorem, we would have used the formula of vector addition. Now, again, if we were using component algebra here, let's see how we solve this by that method. So, question 1 by component algebra method. So F1 we would have taken as some xi cap. Then the resultant would have become 8j cap, because it is given to you that resultant is perpendicular to one of the forces. Okay. And F1 magnitude plus F2, magnitude of F1 plus magnitude of F2 plus magnitude of F2 is given to us as 16. So that means we would have taken the magnitude of F2 as some 16 minus x, which we don't know the angle of it. So then we would have said that F2 is equal to the resultant minus F. Okay. Because so this would have become F2 would have become 8j cap minus xi cap. We just assume, okay, this is an assumption. We're doing by component method, so we are assuming that F1 is along the x-axis and R is along the y-axis, because they are perpendicular. So the resultant is, of course, the sum of F1 plus F2. So we can also express then the vector F2 as the resultant minus F1. So the resultant is 8. Okay, so this becomes the case. So F1's magnitude is x. F2's magnitude is square root of x square plus 8 square, which is also 16 minus x. So now we can find out x from this. So x square plus 8 square is equal to 16 minus x whole square. To solve this whole equation, we'll get the same thing. We'll get x as 6. So that means 16 minus x should be equal to 10. So now we know that actually F2 is the one which is smaller than F1. So that actually means that F2 is the one which is 6I cap, and F1 will become the one which has 8J cap minus 6I cap, because F1's magnitude will become 10 and F2's magnitude is 6. This becomes this function. And the resultant is actually perpendicular to F2, not to F1, because F2 is the smaller of the two forces in magnitude. Okay, so hope this question is clear fully. Next, I'll be moving on to question number 3 and then 5. A couple of students have asked for question number 3 as a doubt. We'll discuss that next, and then we'll move on to question 5, then 6, 7, 12, etc. So, just leaving you with a moment to go through this. If there's any doubt, discuss with me. All right. So next, let us move on to question number. The second is also doubt, Savish. Okay. So question 2, let's go through that. Okay. The component of a vector. Okay. So suppose we have a vector E such that its magnitude is capital E and angle is theta with respect to x-axis. Then, for example, the x component is A cos theta, and the y component is A sin theta. Take any component, like we, for example, take a component. For example, we take the x component. So that is Ax equal to A cos theta. Now, what can we say about the component? The Ax, can it be greater than A? No. But can it be equal to A? Yes. Because theta can be 0. On the other hand, can it be 0? Yes, it can be 0 also. It can be minus A also. Okay. So, accordingly, let's say. So, the component is always less than the magnitude, not necessary. Always equal to magnitude, not necessary. Always greater than magnitude, in fact, never possible. Okay. So, A and C are also not correct option. Why? Because it says always less than its magnitude. अगर A बोला होता sometimes less than a magnitude or maybe less than magnitude, then it's okay. But it's saying always less than. But ऐसा नहीं है ना? It can also be equal to. Okay. And similarly, C is saying always equal to magnitude. Always तो ऐसा नहीं. It may be, but maybe less than also. That is why both those options are wrong. And option B is also wrong because it's never greater than in fact. So only one option is left. So that correct option will be B. None of these. Moving on to question 3. This one is saying that a displacement vector makes an angle 30 degrees with the y-axis. The displacement vector makes an angle 30 degrees with the y-axis and an x component of 10. Okay. So the x component is positive. That means it's lying in which quadrant, and it's making an angle of 30 degrees with the y-axis, the positive y-axis. So that means the vector can only lie in one place. That's the first quadrant. So it's lying like this. This displacement vector is such that its x component is 10 and the angle is making with the y-axis is 30 degrees. So that means the angle is making with the x-axis is 60. So this angle is 30 degrees. This is SY, whatever this is. S. So we know that Sx will become S cos 60, or that's the same thing as S sin 30, and that is given to us as 10. Okay. So that means S cos 60 is equal to 10, or we can say S sin 30 is equal to 10, whichever of the two values. So that means S is becoming 10. Because cos 60 or sin 30 are one and the same thing, which is half. So the vector S is actually 10I cap plus 10 J. It has theta with respect to x-axis as 60 degrees, and therefore magnitude, and therefore x component of 10 and y component of 10. Okay, so that's the third question. Now moving on to the fifth question. Okay, so fifth is a very interesting question. We'll discuss in detail. First, we need to go through this once. Okay, now let's come to the fifth question. Fact is saying that resultant of which of the following may be equal to 0. So in A option, we have vectors of magnitude 10 newtons, 10 newtons, and 30 newtons. So basically, suppose magnitude of A is 10, magnitude of B is 10, and magnitude of C is 30. Then can A plus B plus C be 0 or a null vector? That is the question. And the answer to this is no. Because, as you know, if A plus B plus C were equal to 0, then C would be equal to mod of minus A plus B. I mean, C would be minus of A plus B. That means the magnitude of C would be equal to the magnitude of A plus B. Then according to triangle law, the magnitude of C should be less than equal to this, or C should be in this case less than equal to 20. Therefore, C cannot be. That's why this option is ruled out. Now, by similar logic, we'll rule out the other options, and we'll see which one of them is correct. So this is the A option. The A option is can the resultant of 10, 10, and 30 be 0? The answer to that is no. Or you can also understand this geometrically. Or you can understand it this way, that if A plus B plus C is 0, then they should form a closed triangle. There must be something like this. Because C should be the negative of A plus B. So this is A and this is B. The vector C should be opposite of the vector A plus B, which would be this one. So in any triangle, C is less than A plus B. So in this case, it's less than equal to, but it can also be a case that the angle theta over here, in fact, can even be 180 degrees, in which case C is equal to A plus B. I mean, it can also be 0, in which case it can be. Okay. So that is this part. Now let's look at the other options in this. So the B option, now B is more interesting because it's talking about 4 vectors of magnitudes 10, 20, 30, and 40. So we'll have to do this now like this, that suppose vector E has a magnitude of 10, vector B has a magnitude of 20, vector C has a magnitude of 30, and vector D has a magnitude of 5. So the question is, can this resultant, can it be 0 or a null vector? Can it be? So let's understand this question, that suppose E plus B plus C plus D is equal to 0. Now let me assume that E plus B का resultant कुछ R है. So then it implies that R plus C plus D is equal to 0. And this also implies that R is less than equal to E plus B. यहाँ पे जो E plus B का resultant है, that has to be less than equal to 30, because let's go up and you can see that E and B had a magnitude of 10 and 20 each. So if I'm assuming that R is the sum of A and B, vector sum of A and B, that means R's magnitude is less than equal to the sum of the magnitude. So R is within this limit. Now come to this thing below. So it says R plus C plus D is equal to 0. So D must be equal to minus of R plus C. So that means magnitude of D must be equal to mod of R plus C. Now in this, R's magnitude we don't know, but we know that magnitude of R cannot be greater than 30. And C's magnitude is given to us as 30. C's magnitude is given to us as 30. So then what can we say about D's magnitude? D's magnitude is less than equal to the magnitude of R plus magnitude of C. Okay, so that means D's magnitude is less than equal to 60. Because हमें exact value नहीं पता R का, but पता है कि whatever happens, R's magnitude cannot exceed 30. So that means D's magnitude cannot exceed 30 plus 30, 60. Okay. And given that mod D is equal to 40, so that means this possible. So that is why option B is possible. So I'm just leaving you with the solution for a few seconds, bit of time. So basically we are applying the triangle inequality twice. So we are taking the sum of 4 vectors, be 0. So we are applying triangle inequality 2 times in succession. So I'll explain to you what we are doing geometrically also here. It's very interesting. But first, just understand it by the algebraic kind of method. Okay, so remember what was given to us is A is 10, B is 20, C is 30, so, and D is 40. What is given? So that's how this thing comes in. Okay, so hope this is clear, people. Okay. Now, similarly, let us check the other options. So option C is saying that we have forces of magnitude 5 newtons, 10 newtons, 20 newtons, and 40 newtons. Now you can see this will not be possible because this one is larger than the sum of these three. The sum of these three is 35. You'll see this is not possible. Okay, so let us say here that E is of magnitude 5, B is of magnitude 10, C is of magnitude 20, and D is of magnitude 40. So if E plus B plus C plus D is equal to 0, and suppose we take E plus B as R, so it implies that R is less than equal to this in magnitude. So R is less than equal to 15 in magnitude. R cannot exceed 15. Therefore, since E plus B plus C plus D is 0, so I can replace A plus B as R. So R plus C plus B is 0. That means D is minus of R plus C. So D's magnitude is equal to magnitude of R plus C, which would be less than equal to R plus. And this C is given as 20, whereas R we don't know, but we know that it is less than equal to 50. That means D should be less than equal to 15 plus 20. So D should be less than equal to 30. Therefore, D cannot be 40. So therefore, option C is not possible, or the sum of those 4 vectors is 0 if their magnitudes are according to this. Okay. Same logic, just the way we've applied for the third part, so for the second part D, like that we applied for the third. Okay, and option D is none of these, so we don't need to check that now because you can see option D is correct. Okay, so next time we're going to move to question 12, 12, 13, 14, 16. Oh, wait, question 6 and 7 also group has asked. We'll go to 6 and 7. 6 is actually very similar to a question we have done in one of the exercises. Okay. Only there I had given to it in diagram form, and here it's given in word form, language form. So question 6 has our that we have 3 vectors which are whose directions are along the sides of an equilateral triangle taken in same order, but their magnitudes are 1, 2, and 3. So let's say that vectors E, B, and C have directions along the sides of an equilateral triangle. Let's say triangle PQR in order, but the magnitudes are 1, 2, and so let me first say that let me assume that this is my equilateral triangle. PQR, and suppose this is a triangle of some magnitude. So let's say its magnitude is 1. The sides are magnitude 1. So now what is happening? My vector E is along PQ, and of magnitude 1. So vector E will be like this only. But my vector B is along QR and its magnitude is how much? Its magnitude is different. Its magnitude is 2. So this vector will become like this. So this will be my vector B. Because its magnitude is equal to 2 units. So it's longer than this. Okay. And similarly in the same diagram, my vector C will have to become something like this. My vector C will be longer. This will be vector C because its magnitude is 3 units. But they are along the sides of the equilateral triangle. So their placement has to be like this. Their mutual orientation has to be like this, where you can see that this angle is 120 degrees and this angle is also 120 degrees. So now there are two ways of doing this. One is the very simple thing that we apply component algebra. So convert to components. We do that. It's pretty simple. So what we can do is we can just take those vectors and place them in this xy plane with the proper angles and everything. So you will see that vector E in this diagram now. Vector E would lie somewhere here, let's say. This magnitude is 1 unit. But vector B would in comparison lie over here. Like this. It's at 120 degrees to lie something like this. Its magnitude is 2 units. But this angle is 120 degrees. And vector C, where would that one lie? So vector C would now lie in the third quadrant. Like this. This would be vector C. 3 units in magnitude. But more importantly, this angle would be 120 degrees. So this is how you place the vectors A, B, and C in the Cartesian coordinate frame, in which we have taken our x-axis along the vector E. We have converted the language of the question and the diagram from the language to this. We have converted this to component form. So now next thing we'll do here is we will express A, B, and C in component form. So express vectors A, B, and C in I cap, J cap notation. And then find the result. So just try this out. This exact question we've done before. But here the language of the question is given instead of the diagram. So do it this way. In case you haven't done this question, just try it out by, or even if you've done by some other method, try by this now. Have any of you used some other method while doing this question? Pratyush or Sarvesh or Dhruv, you've tried by some other method? Or Samarth? Okay, because this is not the only method of solving the question. I'll discuss. There are more ways of doing this also. Now this is question number question number 6 of exercise 1. Question number 6 of exercise 1. Yes, sir. But Sarvesh, you can't use cosine rule here because they are not forming a closed triangle. The cosine rule, remember, applies to a triangle. Here the vectors are placed along a triangle, but they are not forming a closed triangle. We can't really use that. So anyway, I'll explain to you how we can do this by other method also. So anyway, coming back here, in component form, we can write the vector E as I cap. The vector B will be at 120 degrees to the x-axis and 2 in magnitude. So remember, cos 120 is minus half, so it will become minus I cap. And sine 120 is root 3 by 2, so it will become plus root 3 j cap. And the vector C, you can see, is making an angle of 120 plus 120 to 40, or this angle here will become 60. So its x component will be minus of cos 60. So it will be minus 3 by 2 I cap, and y component will be minus sine 60. So minus 3 root 3 by 2. These are becoming the vectors A, B, and C. So the resultant, which is the vector sum of A, B, and C, will have an x component which is 1 minus 1 minus 3 by 2, and a y component which is 0 plus root 3 minus 3 root 3 by 2. So this will become 3 by 2 I cap. So minus 3 by 2 I cap. And this factor, if you take root 3 common, okay, so this will become okay. Yeah, so much. You can just check your internet connection with SCPs. So this is becoming the resultant of B plus B plus. So as you can see, the resultant is okay. So now you can check out the magnitude of the resultant will be square root of 3 by 2 whole square plus root 3 by 2 whole square. So that is root 6. And also you can see that the resultant will be at theta equal to tan inverse of 1 by root 3, but in quadrant 3, because both the x and y component are negative. So that will become 180 plus 30, or 210 degrees. So the resultant is making an angle of 210 degrees with respect to positive x-axis. So that means if this was a vector E, which was along the x-axis, then the resultant of these three vectors is somewhere like this. Where this angle is 210 degrees. Just a minute, I'll check the answer. Oh, sorry. by 4. Root 3. 2 whole square by 4. Root 3, that's the correct answer. So the resultant has a magnitude of root 3, but this angle is 210 degrees because it's in third quadrant, because both the x and y components are negative. So if you look at the resultant as a vector, both the x and y component are negative. So that's why it's lying in third quadrant. That's why it's 180 plus 30, because we're using that formula. Tan of 180 plus theta is tan. So tan of 180 plus 30 is tan 30 1 by 2. So this angle now will become almost 360 minus 210, so 150 degrees. So we can say that R is at 150 degrees with respect to the vector. Yeah, Sarvesh, that's what I've explained in detail, Saurabh and Sarvesh. I've explained that in detail over here. Just what I was explaining before. The resultant you have got as a vector, so Rx and Ry are the same distance. So you can see that tan theta is Ry by Rx. So that is 1 by root 3. But it's in third quadrant. So it's tan inverse 1 by root 3 in third quadrant. So that's why we are using this form. So this will give you the answer to the 7th question, I think, where it's asking for. So this is the answer to the 7th question, whereas this is the answer to the 6th question. It's just asking for the magnitude of them. So magnitude of the resultant, this is question 6, and the angle it is making with respect to the vector E, that is question 7. That I explained. Yes, this is a JEE level question. But the thing is, see, by component algebra, you can see this question is quite easy. There's nothing really difficult about it. Now we can also do this question by geometry. So question 6 and 7 by geometrical method. So you can see that your vector E, then your vector B, then your vector C. They're like this. According to the language of the question, they are along the sides of an equilateral triangle. Using the properties of equilateral triangle, this angle is 120 because this is 60. This is 60, so this is again 120. And this is 60, so again this is 120. But their magnitudes are 120. So we can just treat E, B, and C like displacements. So if E, B, and C are displacements, then R, which is E plus B plus C is the resultant displacement. So how we'll find the resultant displacement, let's understand. This is just like the geometrical method we used for displacements earlier. So we start from some origin point and we complete the displacement A and we reach here. Then from this point we are making the displacement of B. So that means we would go at 120 degrees, but to a displacement of 2 units. We'd end up somewhere here. Complete a displacement of 2 units. We reach here. But this angle is 120 degrees. Okay. And then from that point, we are completing the displacement of C, for which we'd again turn 120 degrees and we go like this. We'd end up somewhere here. This would be a displacement C of 3 units, but such that this angle here is 120 degrees. Okay. Now, given this diagram, what would be a resultant of A, B, and C? The resultant, which is A plus B plus C, would be which one? It would be the, now you've gone from O to this point to finally this point. So where you ended up here. This is your final position. And this was your only initial position. So what is the resultant over here? It is this. This is the resultant. So now the question is, can I find the magnitude of the resultant and the direction using geometry? So the answer is yes, we can, because notice what is happening. This angle is 60. This angle is 60. So if I just continue this and make it a triangle, this triangle is becoming what kind of a triangle? It's becoming an equilateral triangle. Provided I've drawn this correctly, I'm just extending this. So I want to extend this line. From the origin to that point, this angle would also be 60. So what would happen is, in this diagram now, this side would have to become 2 units, because this side is 2 and this is 1. So that means this would also become 1. Okay. And this would also become 1. So very interestingly now, what would happen is, this smaller triangle here, this one, this would be an isosceles triangle. Okay. Because 2 sides are 1 and this exterior angle is 60. So this angle here, we suppose alpha. So this angle would also be alpha. So alpha plus alpha would be the exterior angle. Which is 60. So alpha would be equal to 30 degrees. So we can use the property of isosceles triangle and solve this. Okay. So that triangle I'm drawing again over here. That isosceles triangle which I've drawn above would be like this. Something like this. So this side is 1 unit. This side is 1 unit. This angle was 60. And what we're trying to find out is this one. So trying to find out this side. So we just found out that this angle is equal to this angle is equal to 30 degrees. So now next what we can do here is, when use the property of isosceles triangle, that if we drop a perpendicular, we get 2 congruent triangles. Let's say this is x and this is x. immediately we can see that x is equal to 1 into cos alpha, because cos alpha is based upon hypotenuse. Okay. So x would come out to be root 3 by 2 units, substituting the value of alpha. So what about the magnitude of r? That would become 2x. So that would become root 3 units. And also, what about now? Where was our original vector a in this? Our original vector a was here. We also had to find this angle that the resultant vector r was making with this. So that is this angle. Let's say this angle here is beta. So beta is 180 minus alpha, or 150 degrees. So therefore, we can see that the magnitude of r, which is the magnitude of a plus b plus c in the above diagram, is coming out to be root 3 units. That's the first thing. That's question 6's answer. In question 7's answer, the angle of r with respect to the vector e, which in my diagram is beta, is equal to 150. Which we had also got by the component algebra. So this is the alternate way of doing the question, by making use of a geometrical method. Okay. So first you convert this diagram to this, where you're looking at the sum of the vectors a plus b plus c by drawing the vectors head to tail. So you draw the vector a, then from a you draw the vector b, then from b you draw the vector c. Like this. So now in this, what is the resultant? Where is the resultant vector, which is a plus b plus c? It is from the origin of a to the head of c, because you draw all the vectors head. So when you draw this diagram properly in detail, you see that this figure that you're getting is very interestingly, it is an equilateral triangle plus another isosceles triangle. So you make use of that geometrical interesting property that you can break this figure into an equilateral triangle on this side and an isosceles triangle on this side, and then we can use the special properties of isosceles triangle and solve it. Okay, so this is a more interesting way of solving the question, though it's a little bit more complicated compared to what we just did in the component algebra method. Okay, there we just applied our normal formula of components and resultant of vectors by component method. Okay, so take this down, and next we will be going to the question number, I think next on our list is 12 or 13, something like that. Yeah, so 12 and 13. Let me write down the questions. 12, 13, 14, 16, 17, 19, 21. Also 15. Okay, also 8 and 10. We'll do 8 and 10. Yeah, Saurabh, how we got the angle from method 1 is, see, in the first method, the vector algebra method, I mean in the component algebra method, we got the resultant as this, no? We got the components of the resultant. So कोई भी vector के अगर components पता है तो हम उसके angle कैसे निकालते हैं with the x-axis? By using this formula, that tan theta is y component divided by x component. So this is the method that we use. but keeping in mind that both y component and x component are negative, which means that the angle that we get from tan theta formula here will be in which quadrant? Quadrant 3. So for quadrant 3, then we use this formula further. So that's how we found out that the vector r is making an angle of 210 degrees with respect to the x-axis, and the vector e is also along the x-axis. So the angle between them, instead of expressing as 210 anti-clockwise, we'll express it as 150, which is the clockwise angle. Because in the angle between two vectors, we are not forced to say clockwise or anti-clockwise. It's just the easier of the two angles. Okay, so next, moving on to question number 8. So it says a body is constrained to move only along the y-axis under the action of a force of this much. So the force acting on the body is minus 2i cap plus 15j cap plus 6k cap, and the body moves to a distance of 10 meters, but such that it is constrained to move along the y-axis only. So the fact that it's constrained to move along the y-axis, that means when it moves 10 meters, it will be moving 10 meters along the y-axis. So this is the displacement in meters, this is the force in meters. So work done by that force is equal to force into displacement along force. Okay. That is the word meaning of it. So in component algebra or in vector algebra, that becomes scalar product. So work done is dot product of force and displacement. So here it is dot product of, it simply becomes the dot product of these two things. It will be the force which was minus 2i cap plus 15j cap plus 6k cap, dot product with the displacement, which is 10j cap. As you can see, that will become 150 Newton meters or 150 joules. So this is something that we'll be studying in more detail in the chapter called work energy theorem, which will come later, after Newton's laws of motion and friction and all that. So 2 or 3 chapters down the line, we'll be studying this definition in more detail, but you can understand this from now on, that this thing converts to this. So this is what we have to do in question number 8. 2 or 3 of you have asked me that. So moving on to question 10, which is the next question people have asked. So question 10 is again about understanding the direction of cross product property. So it says that vector E is vertically downwards. You can think of it along the acceleration due to gravity. Like in kinematics we study, whereas vector B is towards east. So now we have to give the direction of A cross B. It's a direction here. So let's understand it this way, that suppose we think of a horizontal plane like this. So this is a horizontal plane. So gravity is pointing like this into the planes. So what is the direction of my vertical axis? It's this one. So let me take Z axis as vertically upwards. So negative Z axis is vertically downwards. Now in this, suppose my geographical axis north, south, east, west are pointing like this. This is north and this is east. So I can take my x axis along east. Automatically my y axis is becoming along down. And this is y prime, which will point south. And this is x prime, which will point west. So in this now, where is my vector E lying? My vector E is lying along the x axis. Oh, sorry. Vector is vertically downwards. So it will be along minus E, or E will be some magnitude into minus k cap, because it is vertically downwards. Whereas vector B will be some magnitude into I cap, because it is eastwards. You can see in the diagram that vector B will point towards the east. So in my diagram it will point along my positive x-axis. So A cross B, the direction क्या हो जाएगा? A cross B will become minus A K cap cross B line. So it will be minus AB into K cross I. Now K cross I क्या होता है? J होता है. So it is minus AB. You can see that its direction is along negative of J cap. So it is southwards. So the direction is minus J cap or southwards. Or you can imagine this diagram in 3D and apply the right hand thumb rule. So point your thumb downwards and your fingers towards east. So you'll see your palm is pointing towards south. So in this diagram, if you point your thumb downwards and your fingers eastwards, you'll see that your palm is pointing in this direction. Pointing southwards. क्यों zero बेटा? Perpendicular vectors हैं. Perpendicular vectors का cross product zero क्यों होता है? K cross I is J. This minus AB होता है. Minus J is southwards, ना बेटा? It's not plus 0. There is this minus sign here. See this minus sign? E cross I is J, but the minus sign is there. Na? That's why it is minus J. It's negative of some quantity into J. So direction क्या हो गया? Minus J. Is it clear now, Sarvesh? Okay, hope it is clear to you, Sarvesh, why it is minus K, because it is negative of AP into J cap. A and B are magnitudes, na? They are positive quantities. So it is some negative quantity into J cap. So उसका direction कितना हो गया? क्या हो गया? Minus J हो गया, not plus J. Yes, sir. What is the problem? See, take the cross product of these two. Here, you know that E cross I is J. So that's why your vector E cross B is becoming minus of AB into J cap. It's a negative quantity into J cap. So what is the direction? It's the negative y-axis. So that's towards south. No, you're confusing something. You're confusing dot product with cross product. यहाँ पे cross product है. This is the rule for cross product. Dot product zero होता है. Cross product zero नहीं होता है K और I का. Question 10. And already I've written the symbol also, so it should be clear to you what we are doing here. We are calculating cross product. Dot product is a scalar quantity. Because dot product का direction पूछने का कोई मतलब ही नहीं होता है. The question is asking what is the direction of the vector product. That is the cross product. No, we are not discussing question 9. Nobody has asked question 9 yet. So I am assuming question 9 is done. If anybody has a doubt in question 9, we can discuss. We are discussing question 10. Now next we are going to go to question. Just a second. Let me down somewhere. Yeah, so 8 and 10 are done. Next we are doing question 12. Let's come to question 12 next. Okay. If you have a doubt before question 12, anything which I have not done yet, please send it to me. I'll do it after 12. Okay. If it says 5 equal forces, so what they mean by equal forces is equal magnitude forces. At a point such that all are lying in one common plane. That is normally what we call in vector algebra coplanar. All 5 vectors or all 5 force vectors are coplanar. And the angles between any two adjacent vectors is 0. So we have to find their resultant. So let me explain the question in terms of a diagram. What it means that at a particular point there are 5 forces acting. All 5 of them are coplanar. So they are all lying in the plane of this, let's say 3, 4, 5. Now let's just assume that all 5 forces have the same magnitude and are coplanar. So mod of F1 is equal to mod of F2 is equal to mod of F3 is equal to mod of F4 is equal to mod of F5. And let's say that is some F. So all of them have the same magnitude. And also it is given that whatever this angle, same this angle, same value, this angle, same value this angle, same value this. So that theta will become how much now? You can see theta will become 360 by 5 or 72 degrees. So we have to make use of this. And now we have to find the resultant of these vectors. This question. So resultant we have to find out. So we can see here that if you use component algebra, then we'll have to find out sine and cos of 72 and all that. And for that, we'll have to use a calculator. So we can do that, but let's keep that aside. Okay, let's see if we can do something else. So how can we solve this geometrically? Geometrically, we'll understand that if we draw a regular pentagon, it will take me a bit of time. Pentagon is something that easy to draw. Very tight. You can see a regular pentagon has this property that all sides are equal, and therefore we join them to the centroid of the pentagon. C is the centroid. Then these angles are each one of them 360 by 5 or 72 degrees. So this should give you a clue that there also the angle was 72. And not only that, now you also see that this angle will be equal to this angle because this side is equal to this side. So this is some alpha. This will also be alpha. So alpha is 180 minus theta by 2. And that is why now this exterior angle, this is also alpha. This exterior angle becomes how much? It also becomes theta. Because whatever that exterior angle is, 180 minus 2 alpha, theta is 180 minus 2 alpha. You can see this theta is the same as this. So that theta is also 70 degrees. So this is what we notice about the geometry of a regular pentagon. This is the geometry of a regular pentagon. That is that each side subtends an angle of theta equal to 72 degrees at the centroid C. That's the first thing. And the second thing is therefore each exterior angle, each of the sides makes an exterior angle with the other, which is also equal to the same. Theta equal to 70. This also tells us that the exterior angle between two sides, any two sides, is also theta equal to 70. So just note down this fact about the regular pentagon, and then I'll show you how this is used in solving this particular question. So the idea is, this geometry should be known to you as part of your plane Euclidean geometry. And if this geometry is clear to you and it strikes you that theta equal to 72 degrees occurs for a regular pentagon, then it will strike you how to relate this vector question, this one, with this geometry next, which we'll see. Okay. Otherwise, you have to use the component algebra. In this case, you will have to look up the values of sine 72, cos 72, and more angles like that from the table or from a calculator or something, and the question will become very tedious. It's not that it cannot be solved, but the elegant solution or the easy solution is by making use of this geometry of the regular pentagon. So I'm just leaving you with a minute to note down this geometry. And if you already noted down, then try to relate this with the question itself, and you'll see how you get a solution. It's a very interesting question in that sense. Okay, so people, next up, let's understand how to use this over here. So see, if I go back to my earlier figure, where I had drawn the 5 vectors, F1 was, let's say, this one, then F2 was this one, then F3 was this one, and F4 was, let's say, like this one, and finally F5 like this. Yes, they form, if we draw them head to tail, you see, because this side is equal to this side, equal to this, and this. And these angles are all 72 degrees. So they will form the consecutive sides of that regular pentagon. So if I want to find out the resultant of F1 plus F2 plus F3 plus F4 plus F5, by the same kind of principle that we used to apply in triangle law, we will, for the sum of 2 vectors, here we do it for the sum of 5 vectors. We'll draw F1, and then from the head of F1 we'll draw F2. Then from the head of F2 we'll draw F3. Then we'll draw F4. And when we draw F5, we'll see we are back to where we started. So that means the resultant is how much? 0. Because all of them have same magnitude. So we see that F1, F2, I guess up to F5, drawn head to tail form a closed shape, a closed polygon. In this case, is a regular pentagon. Therefore, the resultant. So that becomes a complete solution. Yeah, the other method as I told you is that you write your vectors in component algebra. So you write F1 as F I cap. You write F2 as F cos 72 I cap plus F sin 72 J cap. Like that, F3 will become F cos 72 plus 72. So that is 144 I cap plus F sin. Like that, you write all of these. And you use a calculator to find cos 72, sin 72, cos 144, sin 144, and all these angles. And you do the resultant sum that way. But as I told you, that's a very lengthy and tedious method. It should basically strike you that, see, when we are drawing the vectors head to tail, the final vector's head is at the tail of the first vector. So the resultant is 0. So what this tells us is that the final vector F5's head meets at the first vector F1's tail or origin. Okay, so that's why the resultant is. So this final vector's head is coming back to where the origin of the first vector is. So that's why the resultant of these vectors is becoming 0. They are forming a closed shape. So the resultant is. Okay, so this is your 12th question. So next, I'm going back to 9th question. Yes, if they were unequal, then they might have been non-zero. The different angles also could have been non-zero. So if they were different angles, then this regular polygon, or this, in this case, this pentagon, would not have come in any use for us. So then it would be better to go with the component algebra method, this method. This method would be easier if they were different angles. But here, because the angles were same, it should have struck us that they will form a regular pentagon. Component algebra. If this symmetry was not there, that they are equal in magnitude and the angles are also equal, then we could not make use of the properties of the regular pentagon. Yes. Okay, so there the component algebra method would have been easy. Even in the equilateral triangle question, we were able to break it into an equilateral triangle plus a isosceles triangle. So there was a geometrical way of solving. But अगर completely random होता है, जैसे उस केस में the angles were not 120, 120. There were some different angles, and the magnitudes were also different. So then, what is the general method of solving? The component algebra. So the general method of solving is always the component algebra method. It is only in these kind of cases where you notice that there is some kind of symmetry. So there you can see that, okay, is there a geometrical figure which will make it easier to solve? Okay, so now I'm going back to the 9th question on request of Sarvesh. Then I'll come back to the 13th, 14th, etc. So 9th question is like this. You are given two vectors, E, which is I cap plus J cap, and B, which is I cap minus J cap. And a third vector C, which has a magnitude of E such that the vector C is perpendicular to both A and B. So we have to find this third vector C. Let's try this out. So यहाँ पे क्या है? See, if C is perpendicular to A and B, we can make use of the concept of cross product, because you know that A cross B is AB sin theta n cap, where n cap is perpendicular to A and B. So therefore, C is along n cap or minus n cap, okay, because both these vectors have that property. Okay. So what we'll have to do here is first find A cross B, and then say that, okay, C will therefore become plus or minus of 3 n cap, where n cap is the unit vector of A cross B. And that's the general way of solving this question. So A cross B क्या हो जाएगा यहाँ पे? It is 1, 1, 1 minus 1 k cap. So it is minus 2 k cap. Therefore, n cap is minus k cap. That means the vector C is plus minus 3 k cap. दोनों में से कुछ भी हो सकता है. But यहाँ पे so much was not required. Okay. So you'll actually see that because the vectors AB are in the xy plane, this was not required actually. This much work is not needed, you know, because you can see by plain observation that A and B are in xy plane. Both of them have an x and y component only. You can observe here and see. So therefore, n cap is plus minus k cap. Unit vector perpendicular to both A and B. It has to be either plus k cap or minus k cap. तो इतना करने की जरूरत ही नहीं है. So from here only we can say that C is plus minus 3 k cap. हाँ, but dot product का कोई लेन देन ही नहीं है ना इस क्वेश्चन में. Sarvesh, there is no relation of dot product with this question. So finding a vector C which is perpendicular to both A and B. How can C be 0? Because C is given to you as a vector of magnitude 3. Why you are taking dot product in the first place? डॉट प्रोडक्ट का कोई लॉजिक ही नहीं है यहाँ पे. Understanding? Okay, good. So now let's come to 13th question. So 13th question is similar to one of the questions we've done in worksheet. It is given to you that a particle starts moving from the point A, which is 1, 0, 0, towards the point B, which is 4, 4, 12, at a speed of 65 meters per second. Okay. So now we have to find the position, let's say P, X, Y, Z kuch hoga, at P equal to 2 seconds. So this is where the particle is at T equal to 0 and it starts moving towards AB. Okay. So we can say that again what is happening is, agar ye point A hai aur ye point B hai, so it's moving in this direction of AB. So the velocity vector of that particle has to be along the direction of AB. So that's what we'll make use of. So the velocity of the particle will be its magnitude into some unit vector. Okay, where n cap is the unit vector along the line. So A was this point 1, 0, 0, and B was this point 4, 4, 12. Okay. And this velocity had a magnitude of 65 meters per second. That was given to us. So firstly, we can now see that that unit vector will be how much? It will be 3 I cap plus 3 j cap, sorry, plus 4 j cap plus 12 k cap. Okay. Divided by its magnitude. Okay. Because AB as a vector is what? It is 4 minus 1 I cap plus 4 minus 0 j cap plus 12 minus 0. So as a vector is becoming how much? 3 I cap plus 4 j cap plus 12. ये वाला वेक्टर है, the vector joining the points A and B. तो उसका यूनिट वेक्टर अब क्या होगा? वेक्टर डिवाइडेड बाय इट्स मैग्नीट्यूड, so that is 3i plus 4j plus 12k divided by its mod, which is root of 3 square plus 4 square plus 12 square, which you will see will be 13. This whole square. So that unit vector is nothing but 3i cap plus 4j cap plus 12k cap divided by 13. Okay. So therefore, what is my velocity vector? It is the magnitude of the velocity into the unit vector. So magnitude of velocity was 65 meters per second, and the unit vector is this one. Okay. So this will cross with this. So this will become 5 into 3i cap plus 4j cap plus 12k cap, or we can write this as 15i cap plus 20j cap plus 60 k cap in meters per second. This is becoming my velocity vector. Okay. Now I'll ask why I have asked for the velocity vector. Because I have to find the final position after 2 seconds. So to find P at t equal to 2 seconds, what I'll do is first I'll find displacement. So displacement will become velocity multiplied by time. So in this case it will become 15, 20, 60 k cap multiplied by the time of 2 seconds. This is in seconds, this is in meters per second. So the displacement in 2 seconds will become this. So the displacement is 30 I cap plus 40 j cap plus 120 k cap in meters. This is the displacement vector. तो अभी क्या हो रहा है? The particle was at E, which is 1, 0, 0 at time t equal to 0, and is reaching some point P. इसका x, y, z निकालना है मुझे at time t equal to 2 seconds. But that displacement vector between A and B, that displacement vector I know. That is this one. Okay. So next I have to find x, y, and z. So as you can see, x will become 31 meters, okay, because it's going from 1 to 30 I cap. Y is from 0 to 40, so it's 40. And z is 0 to 120. So the coordinates of the point become 31, 40. T equal to 2 seconds. Okay, so this is the solution of it using the concept of unit vector. And this thing. So hope this is clear, people. Because बेटा देखो E के कोऑर्डिनेट्स क्या है 1, 0, 0 ना, और P के कोऑर्डिनेट्स निकालने हैं और ये डिस्प्लेसमेंट मुझे पता है. So this displacement is 30 I cap plus 40 j cap plus 120 k cap. Okay, so hope you understood some of the last part. Why we added. So इसका जो x कोऑर्डिनेट कितना हो जाएगा, ये 1 plus 30 हो जाएगा, बट y कोऑर्डिनेट कितना होगा 0 plus 40 और z कोऑर्डिनेट कितना होगा 0 plus 120. Because see, when you go from some point whose coordinates are x1, y1, z1 to another point whose coordinates are x2, y2, z2, so ये जो displacement vector है वो क्या होता है? It is x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 j cap. So we are just making use of that concept. That displacement is the vector joining the initial point with the final point. So that is the concept we are using here. Okay, so just go through this part, then I will take you through the final part below also. Because it is going from A towards B ना बेटा. Question का language ही बता रहा है that my particle or my body is starting from the point A, moving towards B. So what is the direction of its velocity? It is along the line AB. So direction को हम vector में कैसे express करते हैं? By unit vector. नहीं theta का कोई मतलब ही नहीं बेटा, because here there is no referencing to the xy axis etc. It is from one point to another point whose coordinates are given. So hope this is clear now. Why we are using this unit vector? Now, this is the unit vector along AB. N cap is the unit vector along the line AB. So that is the unit vector, okay, of the velocity V also. Because the velocity vector is along AB. Okay, so once you got n cap multiplied with the speed, so you're getting the velocity's magnitude into its direction, which is the unit vector. So that gives you the velocity as a vector quantity. Once you got the velocity as a vector quantity, then you get the displacement as velocity into time. And from the displacement, you have the coordinates of the final point. Okay, so this was question number 13. Just go through it once more in detail. And next, we are going to do 14 and 15. So come to those questions. I'll explain. So finish writing this down and go through question 14. I'll explain that next. Okay, people, so hope this question is fully clear. Now let's come to the 14th question next. Okay, so question 14, hopefully now you'll be able to understand after we've done a couple of questions like this earlier today, where it is given to you that, let's say we have some arbitrary triangle. It need not be equilateral or isosceles or anything. But suppose this triangle is ABC. Now we have three vectors of forces, let's say, which are proportional to. So F1 is proportional to AB. F2 is proportional to BC. But F3 is proportional to twice of C. Okay, so then the resultant of these three forces will become how much? Okay. So now we just convert this to a vector diagram. So we'll see that this thing now corresponds to a situation where if I pick up this line AB and convert it into a vector, that becomes the force F1, which is A to B. But if I pick up this line BC, that will become my force F2, which is B to C. But as far as the third vector now is concerned, F3, that is not CA, it is double of CA. So my third vector will become like this. So this is my F3, where if this side is CA, total length is twice of C. So now you can see that what is my resultant of this? The resultant is from the origin of E to this. So my resultant force is now going to become in this diagram. My resultant force is going to become this one. This is the resultant. Now from the origin of the first vector, which was E, to the head of the last vector. So resultant is, it is the vector drawn from the origin of the first vector F1, which is the point E actually, to the head of F3, which is the point, let's say, this point, E, let's say. So it is basically ED. F3 is proportional to this vector ED. So ED you can see is the same as C. You can see that CD is double of CM. So therefore ED is the same thing as C. Therefore F3 is proportional to ED or C. So the resultant, sorry, not F3, the resultant. The resultant R, it is proportional to the side C. देखना बेटा ये इसके बराबर है ना, ये twice C है ना, just given to in the question na, that F3 is given proportionate to 2 times C. Okay. So therefore your CD is twice of C. So that means CD is equal to C plus ED. These two are equal. Okay. Is this clear now, beta? Samarth, is this clear why ED is equal to CA? E is basically the midpoint of that line CD, na? Because that vector F3 is proportional to double of the third side. Okay. So hope this question is clear to all of you. Let's come to the 15th question. A very interesting question in itself. Now 15th question is given in such a language that you will see that you have to use the triangle law. So it is given to you that the magnitude of two forces are 3p and 2p respectively, let's say. So F1, let's say, is one force. It has a magnitude of 3p. And F2 is having a magnitude of 2p. And suppose the angle between them is suppose theta. Yes. Now it is given to us that if the first force is double, the magnitude of the resultant also doubles. Okay. So you can say that resultant of F1 and F2 is this. So magnitude of the resultant is square root of F1 square plus F2 square plus 2 F1 F2 cos theta. That is our statement 1. Okay. Now it says that if f1 is doubled, then its resultant with f2 also doubles in magnitude. इसका मतलब क्या देखो कि अभी अगर मैं डबल ऑफ f1 प्लस f2 करता हूँ तो वो कुछ नया रिजल्टेंट देगा, जैसे r प्राइम. Now this r prime should have a magnitude that is 2 times r. The magnitude of the resultant also doubles it, right? Okay. So what is this basically saying? That r prime is square root of 2f1 plus f2 2f1 f2, but cos of which angle? Same theta. Why this theta will be the same? 2f1 makes the same angle theta with f2. So now this has to be how much? This has to be 2r. This r prime has to become 2r. That is equal to square root of 2f1 whole square plus f2 square plus 2 times 2f1 f2 cos theta. So this is my second statement. Okay. And in this we will substitute what condition? That f1 and f2 individually have magnitudes of 3p and 2. So in our statement 1 and statement 2 we will substitute these things. So this statement will become what? That r is equal to square root of 9p square plus 4p square plus 12p square cos theta. So r is equal to p into square root of 13 plus 12 cos theta. This is my equation 1 now. And now in this statement I have to substitute the same. So r prime will become square root of 3p के जगह क्या हो जाएगा? 6p हो जाएगा ना. So 2f1 will have a magnitude of 6p. So 36p square plus 4p square plus ये कितना हो जाएगा? 24, because this one is double. So 24p square cos theta. And this is equal to how much? 2r. So 2r is equal to p square, p, bring the p outside the square root. Okay. Yes, very good. Into square root of ये कितना हो जाएगा? 40 plus 24 cos theta. So this is your equation 2 is equivalent. Okay. So now you solve right hand side of both the equations by taking this as double of this. So we get the answer for cos theta. When you solve, your p will cancel out. So compare equation 1 and 2 and solve for cos theta and you will get the answer. Yes, Tanish, that's good, that's correct. Okay. So I think we'll get cos theta as minus half, which means theta is 120 degrees. Alright people, so hope the working of question 15 is okay. Right, so we will conclude the lecture here today. But many of you have also asked me doubts in exercise 2 and some other questions in exercise 1 continued. So if you can just send me those doubts on WhatsApp, I will give you some hint. So maybe you can finish those questions before the next lecture itself. In any case, next lecture, who will be teaching you modulus? Oh yeah, about the books, let me tell you. Yeah. So wait, let me come back to question of books. Okay. So first of all, next lecture we will do some remaining problems of vectors. Okay. Plus we will do introduction to Newton's laws of motion. So for this, for Newton's laws of motion, the reference material we follow at this stage is module. Okay. PDF will be sent to you tomorrow, so you can start reading also. Okay. And second, we will follow this book, Concepts of Physics. HC Verma. Part 1 is for class 11 and part 2 is for class 12. You can start reading this. Okay. So these we will definitely follow. Now additionally, there is some optional reference material which you can follow. So one is Physics by authors Resnick, Halliday and Crane. Okay. This is Wiley Publications. This is for only theory, only for extra theory reading. You can follow this. Okay. Whereas another book you can follow is Mechanics 1, which is part of a series of Arihant Publications. JEE Advanced Physics books by B.C. Pandey. Okay. So this is what we can follow for JEE Advanced extra problems. Okay. For NEET, your module is enough along with HC1. And HC1 also you can do selected questions. That many questions will not be required. So I'll just write down separately for NEET also. For NEET as well as for your AIMS entrance exam. Okay. You can use the NEET module. Okay. Plus selected questions of HC1. That will be enough for me. Okay. So these are additional references, optional references for these students. Okay. These are compulsory. This will definitely be followed. The module and the concepts of physics, HC1. Yeah, for KVPY also DC Pandey will provide good books, and along with that we'll provide you KVPY question papers, so that will be more than enough. Yeah, HC Verma, laws of motion, when we come to that, I will tell you which questions to do. If you have HC Verma already, you can do the questions of vectors which are in the chapter 2, physics and mathematics. Okay, people. So you will get these reference book names in the whiteboard PDF which I will share. Okay, so that's it for today's class, people, and wish you all the best and complete maximum problems of vectors. If you have completed up to exercise 2 most of the questions, then you can go ahead and do exercise 3 and 4 also now. So that's it for today, people. All the best. Yes, Yashmit, HC Verma is used for both JEE mains and advanced. Both the level of problems are there in that. There is sufficient problems for JEE mains and JEE advanced. But particularly for JEE advanced, extra practice from DC Pandey will also help a lot. Yeah, Arihant. That is for extra practice at your JEE advanced level. Yes, you can get it now in 11. So whatever reference I have told you, even the optional ones are for now only, for class 11. Starting from Newton's laws chapter. For theory, your module and HC Verma is enough in the beginning. I have given you the optional thing of that book. For NEET, your module is enough for theory. In NEET, the physics part is not so complicated, so module is more than enough.